Okay. Good morning, students. So, 13th chapter thermodynamics. So, already some part of discussed. Okay. So, that one topic today repeat. So, thermodynamics. So, thermodynamics 0th law and thermodynamics first law, thermodynamics second law. So, discussed. So thermodynamics first law means so the dq is equal to du plus dw. So dq is equal to du plus dw. dq is equal to du plus dw. So dq is equal to dq means so the amount of the heat energy is required or supplied to the system, that is utilized to increasing internal energy, and so some part are used to so work done by the system, so that means so here taken dq, so the dq is some amount of the heat is supplied to the system or to the body. Okay, so that equal. Okay, so du plus dw, so du means so the amount of the heat, that is means internal energy developed, and temperature is increased and internal energy developed. Okay, and so dw means some amount of work done by the system, so dq is equal to du plus dw. Okay, got it. So thermodynamics first law, that is means so similar, just like law of conservation of energy. Okay, law of conservation of energy, just like so heat, the heat flow, the limitations are the taken. It is does not explain the heat is flow direction. Okay, so thermodynamics first law, it is does not explain about the direction of heat flow, and also the amount of it is does not explain efficiency of the heat. Okay, that means so the heat is required to the system, and it is does not complete or converted into 100% work done. Okay, 100% work done. Okay, so that means the two limitations is does not explain, that is the direction of the heat flow, and another one is taken efficiency of heat. Got it. And so now another is taken some is that is taken so sign convention method, that is means sign taken, sign symbols. Okay, so here taken, so for example plus dq, so plus dq means so the amount of the heat is required to the system. Okay, so minus dq means so the amount of the heat is taken out from the system, అంటే దట్ మీన్స్ సిస్టమ్ నుండి మనం తీసేసుకుంటున్నాం, అండ్ సో సమ్ అమౌంట్ ఆఫ్ ద హీట్ ఈజ్ డ్యూ టు ది సిస్టమ్. ఓకే, దట్ మీన్స్ ప్లస్ dq, సో ప్లస్ dq మీన్స్ సమ్ అమౌంట్ ఆఫ్ ద హీట్ ఈజ్ రిక్వైర్డ్ టు ది సిస్టమ్, మైనస్ dq మీన్స్ సమ్ అమౌంట్ ఆఫ్ ద హీట్ ఈజ్ ఓకే సో rejected, or some amount of the heat is taken from to the system. Got it? Okay, so now is taken another plus dw. So plus dw is means so the work done by the system, work done by the system, and so minus dw, that is the negative work done. Okay, negative work done. So the negative work done is taken, that means work done on the system, work done on the system, system పైన మనము పని చేయడం, సిస్టమ్ వల్ల పని జరగడం. సో దట్ మీన్స్ సో వర్క్ డన్ బై ది సిస్టమ్ అండ్ వర్క్ డన్ ఆన్ ది సిస్టమ్ ఇస్ టేకెన్. ఓకే, గుడ్ ఇట్. సో దీస్ ఆర్ ఫండమెంటల్స్. ఓకే, అండ్ సో నౌ what is the CP and what is the CV? Okay, so CP means molar specific heat capacity at a constant volume at a constant pressure. Molar specific heat capacity at a constant volume. Okay, that means here taken molar specific heat capacity at a constant pressure, at constant pressure, at a constant pressure. So that means Cp is taken. Okay, Cp is equal to 1 by mu dq by dt. We can write Cp is equal 1 by mu dq by dt. Okay, so molar specific heat capacity at a constant pressure. Okay, so that heat is required to the system and that is increasing, so temperature. So molar specific heat capacity at a constant pressure, that is in mathematical we can write, so Cp is equal to 1 by mu dq by dt. Cp is equal 1 by mu dq by dt. So mu is called as a moles, number of moles is taken. Okay, so that means what is the Cp? So that means so some amount of the heat is required or given to the system and it is increasing of the temperature 1 degree or 1 Kelvin. Okay, at a constant pressure. Okay, so that heat is called as a specific heat. So that is the molar specific heat at a constant pressure. So Cp is equal 1 by mu dq by dt. Okay, got it. And so molar specific heat capacity at a constant volume, at a constant volume is taken, Cv is equal 1 by mu dq by dt. Okay, Cv is equal 1 by mu dq by dt. Cv means molar specific heat capacity at a constant volume, at a constant volume. That means so some amount of the heat is supplied to the system and increasing that is increasing the temperature through 1 degree or 1 Kelvin at constant pressure. That heat is called as a molar specific heat capacity at a constant pressure. So Cv is equal to 1 by mu dq by dt. Now in this case, so the Cp is greater than Cv. Okay, now prove that Cp greater than Cv. Okay, so Cp is greater than Cv means, so Cp means Cv is taken molar specific heat capacity at a constant volume, at a constant volume that given to the total given to the heat to the system, it is no expansion, no spent of the system. Okay, no expansion of the body. That means increasing of the internal energy only, and that means so only temperature is increasing and internal energy developing only. Okay, so that means the dq is equal only du. Okay, so it is does not work by the system. Okay, got it. And that means, so at a constant volume, so the heat given to the system, no expansion of the body, no expansion of the system, only utilized increasing of the internal energy, only temperature is increasing. Okay, that means so the dq is equal to only du. Okay, but molar specific heat capacity at a constant pressure is taken. At that case, so the heat is given to the system, increasing of the internal energy developing and temperature is increasing. Okay, and also some part are utilized to increasing of the, some part are utilized to increasing of the, so some doing work done by the system, some amount of work done by the system. That means so the amount of the heat is supplied to the system. So du plus dw we can write. dq is equal to du plus dw. Okay. So dq is equal to du plus dw means, so the amount of the heat is at a constant pressure is more supplied compared to the at a constant volume. At a constant volume. That means so the condition is satisfied. Cp is greater than Cv. Okay, Cp is greater than Cv. That condition is satisfied. That means Cp means more amount of the heat is supplied to the system. Supplied to the system. Okay, right. Now prove that Cp minus Cv is equal to R. Okay, now prove that Cp minus Cv is equal to R. Okay, now is taken a cylinder. Cylinder containing 1 mole of the gas. And frictionless piston, frictionless piston, and the area of cross section of the cylinder body is A. Okay, so consider the cylinder containing of the 1 mole of the gas and area of cross section is A. And so the frictionless piston is taken. Okay, so inside of the gas is taken pressure P1 and volume V1 and absolute temperature is T1. Okay, got it. So pressure P1 and volume V1 and absolute temperature is taken T1. Okay, right. So now here Cp minus Cv is equal or prove that. So first of all Cv is taken. Cv means molar specific heat capacity at a constant volume. At a constant volume. So the amount of heat required to the system is utilized to increasing internal energy developed. No expansion the gas. That means so the amount of the heat supplied to the system and increasing of the internal energy. Okay, so that equation we can write. So C V is equal 1 by mu dq by dt. At a constant volume is taken. So mu means number of moles is taken 1. Number of moles 1. So dq at a constant volume V is equal Cv dt. Samikaranam, that means equation 1. Okay, according to thermodynamics first law, dq is equal du plus dw. dq is equal du plus dw. dq is equal dq plus dw. But at a constant volume, dq at a constant volume is taken only du. So equation 2. From equation 1 and 2 we get du is equal to Cv dt. Equation 3rd. So dq is equal, that means so du is equal to Cv dt. So equation 3rd. Okay, correct. So from equation 1 and 2 we get, so equation 1 dq at a constant volume, that is the Cv dt, and so we have taken dq is equal to du. So these two equations are comparing. So du is equal to Cv dt we can write. So that is the equation 3rd. Okay. So now is another is taken. This total at a constant volume, at a constant pressure. So the molar specific heat capacity at a constant pressure. So at a constant pressure, so that we can write the Cp is equal 1 by mu dq by dt. So mu means number of moles. So the mole is taken here 1. Okay. So the mu is equal to 1. So equation we can write. So the dq at a constant pressure. So that is equal to Cp and dt. So equation 4. And according to thermodynamics first law, so dq is equal to du plus dw. That means so it is required to the system, that is utilized to increasing internal energy and some doing work done. Okay, so these equation 5 are comparing of, so dq at a constant pressure P is equal Cp dt, and at a constant pressure P is equal du plus dw according to thermodynamics first law. Okay, these two equations are comparing. So du Cp dt is equal to du plus dw. So equation 6. Okay, now so the continue of the other class. Okay, thank you students.